Hello students, welcome to Elements of Mechanical Engineering, and in this video I am going to explain about hydropower plant, which is also called as hydraulic energy. So why it is called as a hydropower plant or hydraulic energy is because this energy will be obtained from the flowing water. When water is flowing, it will have kinetic energy. With that kinetic energy we are going to generate electricity. So that is why it is called as a hydraulic energy, and the power plant which is used is nothing but hydropower plant. So the layout of hydroelectric power plant is shown in the diagram, and first let us see what are the different components are available and what are the functionalities. First we'll check it out, and then we'll move on to the working principle of hydropower plant. See, first you will see the reservoir and the head of the reservoir, and that reservoir is connected to the dam, and through dam, so there is a pipe which flows. This is a water flow. This is also called as penstock. So this pipeline which is connecting from dam to turbine is nothing but penstock, through which water flows. And in this penstock, so there will be pressure tunnel or gate, so where that water is allowed to flow, and there is a surge tank, and then there is an inlet valve before entering into the turbine, and then actual turbine. So we call it as, in this diagram it is showing, it is shown as simply as turbine, but in some diagrams you can see the powerhouse. In this powerhouse, so there will be turbine blades, and then so there will be electrical generator. Both are coupled together, so that combination of that hydraulic turbine and that electrical generator is nothing but powerhouse. And from that powerhouse, so there will be transmission line. So here in this diagram, water flows, rotates shaft, and then electrical generator, it is shown separately, and then there is a wire or a pipe, what do you call, the electrical line connected, there is a to transformer, and then power lines, that is electrical cable. And you can see beneath there is a draft tube, right? So the remaining water is collected in the draft tube. Actually the water which is collected underneath near the draft tube is nothing but tail race, but in this diagram the tail race is not mentioned here. So these are the components which we come across this hydropower plant. Now let's see the working principle of hydropower plant. So first thing is, the water will be preserved in the reservoir, and whenever you see that water is preserved in any reservoir, or for example um, overhead tank, so every house will have the overhead tank, and the tank is filled with water. And if you look at this overhead tank or reservoir, so water is available inside the tank, which possesses potential energy. Whenever the water is in a static condition, it will have some amount of potential energy. And then when the water starts flowing through the pipeline from the overhead tank, so that potential energy will be converted into kinetic energy. The same principle will happen here in this hydropower plant. If you look at the hydropower plant, so there is a reservoir and water is collected, and so there is a potential energy, and the water is dam is constructed, and there is a gateway, and then whenever this gate is opened, so this potential energy of the water will be converted into kinetic energy, and water starts flowing through the penstock. And then so there is a gate, so whenever we want the water to flow, so the gate will be opened and the water starts flowing. There is a pressure tunnel and pressure gauge, surge tank, and then inlet valve. So what, so why this penstock is required or needed is, so this water has to come from the higher level, which is nothing but dam, so which is somewhere constructed top surface level, from top surface from the earth. So this water is connected from dam to turbine with the help of this penstock. So water starts flowing, and then it will be collected in the turbine. In this turbine, if you look at this is the actual place where electricity is generated. So turbine blades, actually hydraulic turbine will consist of series of blades which will be rotating, and the water will come and hit the turbine blades, and turbine blades will rotate, and then this turbine blades or hydraulic turbine is connected to electrical generator with the help of shaft. The shaft will be rotating in a circular motion. Right. So when potential energy is converted into kinetic energy, water starts flowing through the penstock. So water comes and hits the turbine blades first, and when it hits the turbine blades, the rotor will be rotating, and then the shaft is connected to the rotor. Shaft will also be rotating because the shaft is a rotating element. It is a mechanical element where torque is produced, and this shaft is connected to electrical generator. So there is a magnetic material. Already we have seen in the previous wind energy and other energies. So magnetic material will be available, and which is wound with coils, and whenever this magnetic material rotates, that cuts the magnetic flux, and there will be EMF is induced. That EMF which is induced is nothing but the electricity, right? So whatever the electricity which is produced will be transferred to power lines or power transmission tower, from which it will be circulated, or it will be transferred to transformers, and then from transformers that power which is generated will be um, given to domestic houses for our domestic purpose. So this is how that electricity is generated with the help of this flowing water. So the working principle that we have seen, and once the water hits the turbine blades, the remaining water which will be collected in the tail race with the help of draft tubes. You can see underneath the turbine blades there is a draft tube. When water hits the turbine blades will rotate, and the remaining water will come to the draft tube, and through which the water will be gathered, or will be settled in a tail race. There is a place where the leftover water will be collected. And now we will discuss about advantages and disadvantages of hydropower plant or hydraulic energy. See, as like what I have explained in wind energy, more or less the same thing will be applicable here. The location, the finding of this hydro power plant is little bit difficult, because you cannot construct hydropower plant anywhere. So you have to check whether the frequent rainfall is available and water can be stored. So these type of areas where you can construct the hydropower plant. And second thing is, the second disadvantage is here, you need to the investment cost, the construction cost is heavy. So it takes lots of time, energy, and money to construct this hydropower plant. Once the hydropower plant is ready, then we can produce electricity, and we can utilize this particular resources, hydraulic energy or Hydel energy. It is also called as Hydel energy. So once that construction is over, we can utilize these energies. And these are the few disadvantages what we have spoken about, and then move on to these advantages. Once everything is ready, the hydraulic power plant is ready, so we can continuously produce electricity, and then there is no skilled operators required, as it is we can generate the electricity with the help of idle energy, and it is a continuous process, and then it is a renewable energy, and it is a conventional energy because it started right from the beginning. Okay, so that is why it comes under conventional energy. At the same time, it comes under renewable energy because it can be reused. So whenever this rainfall is available, so it keeps on, it is, so the energy will be reused again and again. So that is why it comes under renewable energies. So these are the what you call advantages and disadvantages of hydel energy. So thank you so much for watching this video.